Number 1, can the average rate of change of a function be constant? Certainly. For example, a straight line, which is not vertical, has a constant rate of change. A vertical line has a rate of change which is undefined, but you'll learn more about that later. But anything besides a vertical line has a constant rate of change, a straight line, that is. So the answer is yes. Number 3, how are the absolute maximum and minimum similar to and different from the local extrema? Okay, well, let me draw a picture to illustrate. So let's say we have this curve. Something like that. Some function, okay, so we have extreme points. These are the high and the low points, if you will. Alright, the absolute extreme would be the highest point on this whole graph. This right here would be the absolute maximum. Alright, and this appears to be the lowest point, so that would be the absolute minimum. Alright, you have other points in between which are also highs and lows, but they're not the highest or the lowest points on the graph, okay? But we can say that within a certain open interval, or you could say a neighborhood. For example, you take this point here, right there, you would define an open interval near that point, or the bottom of that point, right there, where it's a minimum, all right, in that neighborhood. This is a minimum in that neighborhood. That's a local extreme. Okay, so that's a local minimum. So the local extrema are the high or the low points in certain open intervals or neighborhoods in the graph. And a local extreme and an absolute extreme can be the same. For example, in this neighborhood here, let's say, that open interval, the absolute max is also a local max in that neighborhood. Okay. So if you make this neighborhood here, in this neighborhood there's your local maximum and there's a local minimum. All right. Neither of these are the absolute max or min, though, because they're not the highest points in the entire graph, and or lowest points. So you can think of the highest building in a city as opposed to the highest building in a neighborhood of the city. All right, the highest building in the city would be the absolute max, and the highest building in a certain neighborhood of the city would be a local max. Okay, number 5. For the following exercises, find the average rate of change of each function on the interval specified for real numbers b or h. So number 5's function is f of x is 4x squared minus 7. And the interval is 1 to b, closed interval. Okay, so the average rate of change on this interval would be f of x2 minus f of x1 over x2 minus x1. Alright, where x1 would be the 1 and x2 would be the b. So this is going to be f of b minus f of 1 over b minus 1. And then we evaluate the function at these two values. So f of b, plug in the b, that's 4b squared minus 7. And then you're subtracting all of f of 1. What's f of 1? It's 4 times 1 squared minus 7. So I'll put that in brackets because I want to subtract the whole function. 4 times 1 squared minus 7. And that's all over b minus 1. Alright. And this is equal to 4b squared minus 7 minus, this is 4 times 1 is 4, right? So you've got 1 squared is 1, so that's 4 times 1 is 4 minus 7. Over b minus 1. So we can simplify this. We've got 4b squared minus 7 minus 4 minus 7 is negative 3, so that's 4b squared minus 7 minus a negative 3 over b minus 1. Okay. And this is minus 7 plus 3. Minus a minus is plus, right? So this is equal to 4b squared minus 7 plus 3 over b minus 1. And that's equal to 4b squared minus 4 over b minus 1. And you can do a little factoring and simplifying with this. Let me try to find a little space here. Real estate is at a premium on this board. It's not as big as the board I used to use in my classroom, I'll tell you that much. But we can make do. We can factor a common factor of 4 out of these two terms in the numerator. So let me do that. That's factor out the 4. That leaves you with a b squared minus 1 in the numerator over b minus 1. Alright, and then you can factor the b squared minus 1 as a difference of squares, right? The 1 is 1 squared. So b squared minus 1 squared. So that's 4, and then b plus 1, b minus 1. Difference of squares factoring here. Over b minus 1, and notice that you can cancel the b minus 1's. And so that equals 4, parentheses, b plus 1, closed parentheses. Alright? So that's the simplified form of the average rate of change on that interval. Okay, number 7. Here we have p of x equals 3x plus 4 on the interval from 2 to 2 plus h. Alright, p of x equals 3x plus 4 on 2 to 2 plus h. Well, notice what we have here is a straight line. It's a first degree polynomial. Power on this x is 1, that's the highest power. And it's written in slope-intercept form, mx plus b, correct? So the slope on a straight line, that's not vertical, that is. There is no slope for a vertical line, but this isn't a vertical line. And its slope is 3, as we can see in slope-intercept form. Well, the slope is the rate of change on a line. Okay, it's a constant rate of change. It's always 3. The slope is always 3 on a straight line. This straight line, and on this straight line, that is. Its average rate of change has got to be 3 as well. You know, basically we're done, but we want to do the algebra. Okay, so probably if this were on a test and you said what I just said, the prof might dock you some points because you're avoiding the algebra. That's part of the objective of this course, right? Learn a little algebra while you're moving along here. So let's do the algebra. All right, so the average rate of change is p of x2 minus p of x1 over x2 minus x1. So x2 would be the 2 plus h, x1 would be the 2. So we've got p of 2 plus h minus p of 2 all over 2 plus h minus 2. So this is equal to, again, the 2 plus h is the x2. All right, so that's a two-term expression there. So p of 2 plus h, that's, put the 2 plus h in the x, so that's 3 parentheses 2 plus h plus 4 minus p of 2, so that's minus, subtract the whole function, evaluate it at 2, 3 times 2 plus 4. And we can simplify the denominator, just go 2 minus 2, right? So you get just h. That's nice. All right, so I'm going to move this over here, so that'll leave me some room over there, just in case I need it. Over here, let's see. So we've got, distributing the 3 through, we've got 6. 3 times 2 is 6. And 3 times h is 3h. So we've got 6 plus 3h plus 4. And then this, inside the brackets, we've got 6 plus 4. I don't think I need to write that down, right? I'll just write the answer, which would be 10. All right? So 6 plus 4 is 10, so you're subtracting 10. Save a little bit of space here. And that's all over h. So simplifying up here, 6 plus 4 is 10. I'm adding like terms now. And you've got 10 minus 10. So 6 plus 4 is 10, and minus 10 is 0. So all you've got is 3h over h. Okay, the h's will cancel out. So that leaves you just with 3, just as we expected. Okay, so the slope happens to be, or is, the average rate of change, and it's a constant rate of change. It's always 3, no matter what h is. All right. Okay, number 9. We have f of x equals 2x squared plus 1. On the interval x to x plus h. Alright, so the average rate of change on that interval was f of x2, as usual, minus f of x1 over, I should be saying x sub 2 and x sub 1. but I've gotten into a bad habit of saying just x2, x1, alright, but it's actually x sub 2 minus x sub 1, and x1 is, or x sub 1 is x, and x sub 2 is x plus h. So we've got f of x plus h minus f of x all over x plus h minus x. You're going to see this kind of stuff a lot when you do calculus in the beginning. That's why you're practicing it now. Alright? So x plus h minus x. And let me move to the left a little bit with the equal sign, so I'll have some space if I need it. Okay, so this is evaluating. Put x plus h right there in the x. So you've got 2x plus h quantity squared plus 1 minus just f of x, so that's just 2x squared plus 1. All over, simplifying the denominator, that's just h. Okay, so now don't distribute the 2 through 2x plus 2h and then square it. Alright, that violates the order of operations, right? So when you do the when you evaluate this expression, you do the power first and then you multiply by 2. Okay, so you've got 2 parentheses, and now I'm going to square inside the parentheses there. It's not x squared plus h squared either, alright? So here's another mistake, example of a mistake. Square root of x squared plus h squared, say, equals x plus h. Alright, that's the same kind of mistake as I was pointing out here. What you're doing is you're taking a 1/2 power when you take a square root. And you can't distribute the power inside like that. Okay, so I mean, the only way you can multiply is if there's just one term there. If there was x squared to the 1/2, then or rather h squared to the 1/2, then you'd have the h actually absolute value. But you know, you can't, if it's more than one term, you can't do that. Alright, so this does not equal x plus h. Right? Does not. That's a common mistake. Be careful of that one. Alright, that'll bite you when you least expect it. So remember, this is, doing this error is similar to doing this error. If you write x squared plus h squared. Alright? Well, what is x plus h squared? It's x plus h times x plus h. Or, you remember the formulas for these? A plus b quantity squared is a squared plus 2ab plus b squared. That's the way it's usually presented. So this is the same thing. X squared plus 2xh plus h squared. X squared plus 2xh plus h squared. And if you're confused by this point, even though you've seen these before, just go x plus h times x plus h. Use FOIL or whatever method you like to use, this distributive property. And you'll end up with this expression. You won't end up with x squared plus h squared. Trust me, alright? So then you've got the plus 1, and then minus 2x squared minus 1. That would be distributing that negative sign through, or you could think of that as a negative 1 multiplying the inside of that parentheses, okay? So that's all over h. Okay, so this is equal to distributing the 2 through 2x squared plus 4xh plus 2h squared. And I'm going to combine the 1 and the minus 1 right now, and those go away, right? That becomes 0. So you've got minus 2x squared left, all over h. Okay, well, is there anything else we can do simplifying up here on the numerator? 2x squared minus 2x squared, that's 0. So you just have 4xh plus 2h squared over h. Alright, you notice you've got h's in both of these terms in the numerator. So you can factor the h out as a common factor and cancel with that down below. So let me factor first. That's h parentheses. Oh, wait a second. I can factor more out of there. Actually, I could factor a 2, right, out of these two. But I could factor like a 2h, put a 2h here. But it's not going to do any good, really. I don't have anything to cancel with the 2 in the denominator, so I think why don't we just leave it 4x, or 4 rather, 4x, we factored the h out, alright, plus 2h, we factored one of those h's out of there, so we've got 4x plus 2h in parentheses over the h, and the h's cancel. So that equals, finally, 4x plus 2h. Alright, there you go. Okay, number 11. We have a of t equals 1 over t plus 4 on the interval 9 to 9 plus h. So a of t equals 1 over t plus 4 on 9 to 9 plus h. By the way, if you write 1 over t plus 4 on a horizontal line, instead of writing it vertically like I'm doing, 1 over t plus 4 vertically, sometimes you'll see written like this, 1 over, all on one horizontal line, t plus 4. Now this would be incorrect the way I'm writing it here. Just to point that out while I'm thinking about it, this is equal to 1 over t plus 4. Alright? Like that. 1 over t is just its own fraction. The way it's written like this, that's because of order of operations, alright? You do the division before you do the adding. So that's what you're getting here, alright? But if you want to put the t plus 4 all in the denominator, the whole thing, you have to put parentheses around it, like this. So that's 1 over everything here, t plus 4, okay? So just be careful when you write it horizontally like that, or if you see, you know, on the internet you'll see these math problems where they'll ask you to give the answer, and it's a simple arithmetic problem, but involves something written like this, where our order of operations are involved, so, you know, they try to trip you up with those, alright? Okay, well, let's go on. We've got the average rate of change on that interval, so that's going to be a of t sub 2 minus a of t sub 1. Notice we're using t's here instead of x's because that's what this is written in. The variable here is t, so usually that stands for time, and that's all over t sub 2 minus t sub 1. And so that equals, alright, a of, there's your t sub 2, 9 plus h, minus a of t sub 1, so that's minus a of 9, all over t sub 2 minus t sub 1, 9 plus h, minus 9. Alright, move it over here a little bit. So we've got, well, what are these? On top we've got a of 9 plus h. So you have to put the 9 plus h right there where you see the t. So you're going to have 9 plus h plus 4 in the denominator there. So that's 1 over 9 plus h plus 4. I'll put the 9 plus h in parentheses so you'll know that all goes into t in the formula up here. So we've got 1 over 9 plus h plus 4 minus, and then just plug in a 9 for the t up here. That's pretty easy. 1 over 9 plus 4. And that's all over. Simplifying this, 9 minus 9 is 0, so that leaves you just with the h. Alright. Okay, so now we've got 1 over, well, we could just add these. 9 and 4 is 13, so 13 plus h minus 1/13 all over h. Okay. Now what I'm doing is I need to clear these fractions. That's what I'd like to do. By the way, there's at least another way of doing this, which I'll show you after I do this. We could work with these fractions just individually and get a common denominator, okay, and combine them like that. Or we could try clearing the fractions right now, okay. I can write this as h over 1. H equals h over 1. So I've got a complex fraction. Alright, so one way of handling this is to multiply top and bottom by the common denominator of all the fractions in the top and bottom, right? This, this, and this, okay? And that way you can clear the fractions and simplify this complex fraction. Okay, so that's one approach of doing it, which I'm going to do first. Alright. So sometimes that's easier, sometimes it's harder doing it this way. So it's nice to know more than one way of doing it, which I will show you. Alright, now what is the common denominator of all three of these? Well, this is easy. 1's going to be in the common denominator, so I don't even have to worry too much about that. The 13 and the 13 plus h. So 13 times parentheses 13 plus h would be the common denominator for everything. Alright? So I'm going to multiply this times 13 parentheses 13 plus h over 13 parentheses 13 plus h. Now what am I doing? This whole thing, this whole fraction here equals 1. So that's why I can write the equals next here after this one. Okay, because this line still equals that last line, because all I'm doing is multiplying this by 1 down here, and that of course doesn't change the original expression. Alright. However, I can change the form. It's like 1/2 equals 2/4, right? 1/2 equals 2/4. Why? Because 2/4 is the same as 1/2 times 2 over 2. Right? When you multiply these two together, you get 2 over 4. So what did I do with the 1/2? I didn't do anything except multiply by 1, but I chose my 1 so that I'd have a different denominator. Alright? However, they're still equal. 1/2 still equals 2/4. Okay? So you just multiply by 1, and that way you can get a common denominator. You're multiplying by 1 when you do that. So anyway, let's distribute these through. Okay, so this is equal to 1 over 13 plus h times 13. Now this is the numerator, which is multiplying the numerator of this big complex fraction here. Alright, so I'm just going to move that in using the distributive property. 13 times 13 plus h, like that. And then go over here, minus 1/13 And again, I'm distributing that through, so I'm also hitting this term with the 13 parentheses 13 plus h. Okay, and I'm also multiplying this in the denominator times this whole fraction in the denominator there. Alright, so that's all over h over 1 times 13 plus h in parentheses, okay? Okay. So let me do a little erasing of the little example I wrote on the side here. I'm going to need the space, I feel. Okay. So, all right. Well, maybe I got a little space left here. Let's see. So what happens? You're multiplying this times this, and you've got 13 plus h and 13 plus h. All right. You can cancel those 13 plus h's out. And let's see, we've got a 13 and a 13. Those can be canceled like that. All right. Nothing really to cancel here. Probably didn't need to write h over 1 on that. That's kind of wasting my energy, isn't it? But anyway, it helps on the next method that I'm going to use, that I'm going to show you to write it like that. But here we go. Okay, well, this is 1 times 13 basically. These 13 plus h's are canceled out, so you got 1 times 13 is 13. Minus from here, and then you've got 1 times 13 plus h is just 13 plus h, so it's 13 minus, now don't forget the parentheses when you write this, 13 plus h. Alright, and now you're going to multiply that. Well, I guess I can use the 1 over on this. I guess that's okay. Yeah, that works. All right. I'm going to, what I've got here is 13h. Well, let me write that out. Let me write that out. Instead of simplifying too fast here. You've got this expression multiplying, you can think of that as being all over 1 if you wish. But you're multiplying this whole thing, the numerator of over 1, times the h, alright? And then 1 times 1 is 1. So you've got 13h parentheses 13 plus h. Over 1. Okay? So again, you're going h times all of this. Well, that's, you can multiply the h times the 13, and that gives you the 13h, and then you've got the rest of that. Alright. Now don't go 13 times h is 13h, and then 13 plus h times h is 13h plus h squared. Alright. That would be like doing this. What you're doing is multiplying 3 things together. Right? Even though this has 2 terms, you're considering that as 1 term together in parentheses. That's why the parentheses are there. So it would be like going 2 times 3 times 4. Alright. If you went, where am I? Here we go. If you went h times 13 and then h times this, that wouldn't work. Okay? You can multiply the h times the 13 or the h times the 13 plus h, but not both together. Okay, so that would be like going 2 times 3 and 2 times 4, which would be 6 times 8, or 48. That wouldn't be correct, would it? This is 6 times 4 is 24. Or you can go 2 times 4 is 8, and 3 times 8 is 24. Okay? So, basically you're multiplying three things together like this, three factors. So this times this, you could go do it that way, or you could go this times this, and then multiply the rest that way. But don't go this times this and this times that. All right, that's not what's going on there. Okay, so I know it's easy to see here, but over here where you've got all these terms running around, it kind of gets confusing sometimes. All right. Well, what is this? This is your a complex fraction. You're multiplying the top by the inverted bottom. All right, so let me see if I can, well, I just continue on down here. So this is equal to 13 minus 13 plus h. Well, why don't I simplify that? 13 minus 13 is 0, and then that leaves you with a minus h, right? Think of that as a minus 1 here. So this is actually 13, and then minus 1 times 13 is minus 13. So 13 minus 13, and then minus 1 times h is minus h. So that's just 13 minus 13 minus h, which is just minus h. All right. So you've got minus h, and then this is over. Well, what's 13h times the quantity 13 plus h over 1? Well, let's just leave the 1 off. That's just 13h parentheses 13 plus h. All right. Do you see anything that can be canceled? Yeah, right. You can cancel this h with this h. Okay. Now don't go this h with that h. Okay. Because if you cannot factor an h out of these two, you can't cancel. Okay. So, for example, if you have 1 over, no, make that 2 over 2 plus 3, you can't cancel the 2's out and get 1/3. No, no, no. That's equal to 2 over 5, not 1/3. 2/5 is not equal to 1/3. All right? So anytime you have more than one term, if you can't factor a 2 out, then you can't cancel. You could, well, you can't really factor, you don't usually do that, right? You can't factor a 2 out. But you could write it like this: 2 over 2 plus, well, let me write it like this. Two plus 3, let's say, is equal to 2 plus 2 times, let's say, 3/2. Okay? Because these 2's will cancel, that leaves you with a 3. So you can factor a 2 out of that, like that. And then you can cancel up there, right? So you can write the 2 plus 3 as 2 plus 2 times 3/2, or 6/2 if you want to write it that way. But so you can kind of force that factoring if you, know, I don't know, that might help you sometimes. It's kind of unusual, all right? But usually we don't do that, all right? So anyway, you can't cancel the h with that h, because these are 2 terms here. 2 or more terms are a little more tricky, all right? So if you can't factor an h out of these two terms, you could force it like I did over here, but it wouldn't really get you anywhere. All right, it would just make it worse, like it does here. All right, so you just leave it alone. All right, but this has been in factored form, right? This h is factored out, and so you can cancel here. So that equals -1 over 13 parentheses 13 plus h. Oops, forgot to close parentheses. Alright. -1 over 13 parentheses 13 plus h. Alright. So that is the answer, but there is another way of doing this. Okay. Let me show you the alternate method. But first I must erase. So bear with me while I speed this part of the video up. Okay, here's the alternate method of solving this problem. I'm going to go back to where we were, but not all the way back, so I don't have to take up a lot of space and time rewriting all this. I'm going to go to this part where we were before. 1 over 13 plus h minus 1/13 over h, all over h. Okay. So before we took the common denominator of all of these fractions, you could write that as h over 1. But now I'm just going to deal with the top part. So when you're dealing with a complex fraction, you could do what we did before in the previous method, or you could do the top by itself and the bottom by itself. All right. Now the bottom here, the denominator, has just one term in it, so there's nothing really to do there. All right. But in some of the complex fractions, you may remember there was more going on down here where you're adding or subtracting, and so you had to deal with that as well. Okay. So what you would do is just do the top and bottom separately and treat them like their own unique problems by themselves. All right. So I'm just going to focus on the numerator, the top part, and get a common denominator for these two fractions. What would that be? Well, that would be 13 parentheses 13 plus h. All right. That's pretty easy. So what I need here in this denominator is a 13, because I've got 13 plus h, but I don't have the 13. Here I need the 13 plus h. All right, so I'm going to get that, and I'm going to do that by multiplying by 1 like I did before. But I'm going to choose 1 to be 13/13ths. So when I multiply this times this, I will have 13 parentheses 13 plus h. All right, just what I was looking for. And then minus 1/13. And I need a 13 plus h, so I'm going to multiply that by 1 again, but that's going to be 13 plus h over 13 plus h. All right, and that's all over h. I'm going to write that as h over 1. Okay. Let me get that a little darker there. All right. So again, you're multiplying by 1 each time, and remember, whenever you're adding or subtracting fractions, you must get a common denominator first. You can't just fiddle with the numerators when you're adding or subtracting fractions if they don't have the same denominator. Okay. When you're multiplying or dividing fractions, it's a different story. It's easier. Okay, but in this case, it's a little harder. All right, so multiply the 13 times 1, you get 13 over multiply this times this, 13 parentheses 13 plus h minus, and then you've got 1 times 13 plus h is 13 plus h in that numerator, and again you got 13 parentheses 13 plus h in the denominator, and that's all over h over 1. Alright. Now that they have the same denominators, you can just work with the numerators. So that's equal to 13 minus, and then all of this, 13 plus h, so I use parentheses. Put that all in parentheses. If you don't, it's incorrect. If you don't put parentheses, it's going to be just 13 minus 13 is 0, and then minus h is left. Alright? Or actually not minus h, just plus h, because you're not if you didn't put it in parentheses, you're just subtracting the 13. Alright? You have to subtract the h as well. And so that's all over h over 1. And so that's 13 minus 13 is 0. And then think of that as a negative 1 times h is negative h over h over 1. Oops, I forgot my denominator here. Alright, going from here to here, that's 13 minus 13 plus h in parentheses. Forgot to put in the denominators, oops. This is over 13 parentheses 13 plus h all over h over 1. Alright, there we go, there we go. Okay, and so this is 13 minus 13 is 0, and then you got the minus 1 times h is minus h. So this is equal to minus h over 13 parentheses 13 plus h over h over 1. Alright, and now just continue on here. This is minus h over 13 parentheses 13 plus h. Now you take the bottom fraction, invert it or flip it over, multiply by that, 1 over h. Now the h's will cancel here and here. Okay. So that equals, you got the negative though left, negative 1. Think of that as being a negative 1 there, because negative h is the same as negative 1 times h, so you can cancel the h's out. That leaves you with just a negative 1. I'm going to go up here and finish this. Alright, so you've got a negative 1 over 13 parentheses 13 plus h. Alright, and that is again the answer, and it's the same answer that we got before, which is as it should be. So no matter what method you use, you should end up with the same answer or equivalent answer. Alright? Okay.